We have an equation here, but actually we're told that it is true for all values of x, which in fact means that it's an identity, and we can use 3 bars instead of 2 um, to denote that. And we're asked to find the constants p and q. Now, what we can do is expand out the left-hand side and the right-hand side, and then compare coefficients, the numbers in front. For example, if we had, 7x squared plus 1 is equal to p x squared plus 1, then it must be that and this is an identical, then p would have to be 7. So we can use that sort of idea here. Right, let me expand it out. So I can multiply all of these by x. So I'm going to get 2x cubed plus 9x squared plus 10x. And then I'm going to do the same for p. At this point, I'm just going to make a bit more room. Now it's going to be minus p times 2x squared. I can actually write that as minus 2px squared. We tend to write the x is last, and there's an order to things. You put the number first, and then the thing you don't know, and then the x squared. And similarly, I'm going to get minus 9px minus 10p. And that is going to be identical. I'm going to use that sign. You can use equals if you want, just be aware that that's what it is. It's going to be 2x squared plus qx squared. Sorry, 2x cubed, 2x cubed plus qx squared minus 8x minus 4q. Okay, I'm going to tidy this up. So I've got 2x cubed plus 9x squared minus 2p x squared. I've brought them together because they're next to each other, plus 10x minus 9px minus 10p. And that's identical to 2x cubed plus qx squared minus 8x minus 4q. So from this, I can start comparing coefficients. I'm actually going to do one extra step because I think it helps and it's good to learn this. I can factorize out the x squared here, but I can actually factorize it out afterwards. It's going to be 9 minus 2p x squared. It's just then much more easy to make a direct comparison with q. They're going to be the same. And I get similar over here. It's going to be 10 minus 9p x minus 10p. Okay, so I can now compare. I've got q and 9 minus 2p. So I should probably say comparing coefficients. Let me just say again, because this is true for all values of x, it must be that these are true. So q equals 9 minus 2p. And then I've got 10 minus 9p is minus 8. And I've also got that minus 10p is going to be minus 4q, or equivalently 10p is 4q. Don't need those minuses. Right, now the one that looks the most useful because it just contains one of the unknowns is this one. So I can write down that minus 9p is going to equal minus 18. So p is going to equal 2. And then I can use either of the other ones to get q. So let me use this one. Q is going to be 9 minus 4. It's going to be 5. And I could just check that it works. It's going to work here because 10 times 2, because it's possible that there wouldn't be a solution. 10 times 2 is equal to 4 times 5. So I can be pretty confident with my answer, the fact that it worked in that third one. And yeah, it just checks it all works out, is consistent. So there we go. Those, because this is true for all values of x, these must be the values of p and q.